Hello teacher, this video is made by Ling Tong. For the question 1, the first step is to import the data to the Excel, which is shown here. So I click data, I import the data from the text. I use two methods to analyze PXI. Method 1 using average of PXI. Method 2 using median and mode to analyze. From this table, the average of PXI and chart, we can see clearly in June, Central had the lowest level of average PXI, but South had the highest level. In July to September, East had the best air quality and the West had the worst air quality. In October, Central has the best air quality, North had the worst air quality. From the median of PXI, we know that East region had the best air quality from June to October. West region had the worst air quality from July to September. From the mode of PXI, we can know that East region had the best air quality in June, July, and September. West region has the worst air quality in June, August, and September. Therefore, we can know that East region of Singapore has the best air quality. West region of Singapore has the worst air quality between June 1st and October 31st. Here is the worst air quality region, which is the West. How can I get this chart? I analyze the data and then I generate the daily max PXI in West region, which is shown here. Then I use the data to generate the line chart. The advantage of using line chart is we can see the change clearly. The line can going up and also can going down. So from the chart we can see that West region had a serious air pollution in June, which the highest level of daily max of PXI in June is around 227. In July and October, the highest level of daily max of PXI is around 50. In August and September, the highest level of daily PXI is around 45. For the second question 2, construct a 95-inch confidential interval of the mean PXI reading for the 5 months. By central limit theorem, the probability distribution of a random variable will tend towards the normal distribution when n is more than 30. So we can see that our n size is more than 30, so we can use this formula to help us. The first step is to generate the average. So I count the total number and I divide by the size. 95 confidential interval means alpha equals to 0.05. Before I get my standard deviation, I need to count my variance. I use variance function to help me, and then I get my standard deviation. I use count function to help me get size. Then I know my z value. Sampling error is this one times this one. Upper limit is x bar minus sampling error. Lower limit is x bar minus sampling error. Upper limit is x bar plus sampling error. So I get my result. Thus, 95% confidential interval of the mean PXI is from 31.05 to 31.80. I keep into decimal number. For the second part, PXI is more than 30 for months of July and August compared to in September and October. In order to determine if there is significant difference in the proportion of bad air days in the two periods, I need to get this table first. How can I get this information? I generate the daily max PXI first in 5 regions, which is shown here. Then I count the number of days that PXI is more than 30, which is shown in this table. So we know that for 5 regions, July and August, the total days PSR is more than 30 is 143. Similarly, September and October is 127. How can I get the size? Because we know July and August, the total day is 62, but we have 5 regions, so the size equal to 310. Similarly, size 2. September and October, the total days is 61, but we have 5 regions, so the size 2 is equals to 305. Therefore, we can know our P1, P2, and 1 and 2. I set null hypothesis as P1 equals to P2. Alternative, P1 is not equals to P2. We can get critical value Z because we know the alpha is this function to help me get test statistic, which is this value. Since the test statistic value is less than 2.575, it does not lie in the rejection range, so there is not enough sufficient evidence to reject the null hypothesis 1% level of significance. Therefore, we can see that there is no significant difference in the proportion of bad air days in the 2 periods.